Hello, we're doing Chapter 5, Section 5, introducing the idea of complex numbers as roots of quadratic equations, or zeros of quadratic functions. And I know that this is mind-blowing, but one of the things that's nice about this section is that none of the stuff is really that hard. Okay? As long as you get over the square root of negative 1 is I, everything else is just what we've done before. Taking square roots, completing the square. In this section, to be honest, we usually talk about maybe even not including this because it seems kind of trivial. But there's a very important reason why I am going to include this. All right, whether or not these problems end up on an assessment, that we'll decide. Because to be honest, this is kind of trivial. Oh, I'm sorry, the way we do it is kind of trivial. It's kind of easy. It's absolutely not trivial. I didn't mean to say that. Let's I want to talk about, go back to the previous video, the previous example, and we had a function that was like this. We had f of x equals x to the second power plus 4x plus 13. And you can watch the previous video. It was the third problem that I did. Okay, problem number 3, even though I didn't number them. And what we found out was that x was equal to negative 2 plus 3i, and the other answer was negative 2 minus 3i. These two solutions, these two roots, are related to each other, obviously. They look almost exactly the same, except that in one of them, the number being multiplied by the I is positive, and in the other one, it's negative. That's because when I took the square root, and here's the problem, okay? When I took the square root right there, I had a positive and a negative. That's where I get two of them. So here's my positive and here's my negative. These two together, when I look at them together, are called complex conjugates. And as I usually tell people, if there's a name for something that we do in math, that means it's kind of important. Now, complex conjugates are going to show up in pre-calc. We don't really do much with them other than that's what we get every time we solve. But it'll show up way more in pre-calc where you're going to take this and expand it. So again, you're probably getting tired of hearing me talk about pre-calc, but one of the main things about this class is to take, for the accelerated algebra 2, is to push you hard enough, like relay speed skaters. When someone's coming in, they push the next one really, really hard. To push you really, really hard so that you are ready and up to speed for the next class. So that's constantly on my mind. So here's what the complex conjugates are. Here's a complex number, whatever a plus bi is. So a and b are just numbers, all right? So like negative 2 plus 3i. The complex conjugate, the a stays the same, so the real component stays the same, but the imaginary component becomes its opposite. Easy. So let's look at this problem. I don't like that they did this. They're tricking you. This is actually negative 15 plus 2i. Let's write it that way. So it's complex conjugate. The negative 15 stays the same. The real part stays the same. But the positive 2i becomes negative 2i. And that's all there is to that. For this one, you think, well, what's the real part? Well, the real part is 0. This is 0 subtract 4i. So its complex conjugate is 0 plus 4i. Or you can just say 4i. Again, this one, when they switched it, what they're trying to do, they're trying to trick you into saying 2i plus 15. All right, let's turn it around. I get the square root of 3 plus I, and that's 1 times I. So its complex conjugate is square root of 3 subtract I. And this one's just like that one. 0 subtract 8i is what they gave you, so its complex conjugate is 0 plus 8i. So all that you have to do to find the complex conjugate is change the imaginary part to its opposite. If they start out negative, give it to positive, and if it starts out positive, give it to me, positive right here, or positive right here, then give it to me as a negative. That's all there is to that.